In this video, we are looking at piecewise functions. Here's our first example. F of x equals, well, all this stuff. Basically, a piecewise function is a function that is made up of two or more other functions. And the way that these functions work together is what's described right here. If our x values are less than -2, then we would use this first function, -2x minus 5. If we were dealing with x values that were greater than or equal to -2, but less than 4, we would use this middle function, -1/2 x plus 1. And if we were looking at x values that were greater than or equal to 4, we would use this last function, x minus 6. So basically, we could look at a piecewise function as individual functions. Here are those three individual functions. And when we look at which one we should use, we could look at this information on a number line. So this function -2x minus 5, we would use it for x values that are less than -2. This middle function we would use for x values that are greater than or equal to -2, but less than 4. So in between -2 and +4, we see that this middle function is used when x is greater than or equal to -2. So we're going to fill in this hole here at -2, but keep it open at +4 to say that when we're dealing with an x value of -2, we would use this middle function, and that middle function is going to contain all these x values up till 4, but not exactly on 4, because when x equals 4, that's when we should use this last function. The last function when x is equal to 4 or greater than 4. That's our last function. So we can see that the entire number line is covered by these three pieces. If we were going to deal with some questions like, what is f of 0? We're not interested in plugging 0 in place of x in all three of these functions. We have to identify which one we should use based on this information about our x values. If x is 0, we're looking at, that's a number in between -2 and +4. And you can see on the number line that if x is 0, we're using this middle function. So we'll plug the 0 in place of x into -1/2 x plus 1. And we simplify that, 0 plus 1 equals 1. So we would just simply say that f of 0 equals 1. And because of what's described here with our x values, we know that if x is 0, we're plugging 0 in place of x in this middle function. How about f of 4? X equals 4. So which function should we use? This middle one goes up to x equals 4, but not if x equals 4. If x equals 4, we're down here at this third function. So I would plug 4 in place of x into this third function, x minus 6, and the 4 minus 6 equals -2. So f of 4 equals -2. Let's look at these ideas a little bit further by looking at the graphs of these functions. The first function, f of x equals -2x minus 5. And I've graphed the whole line for all x values, even though we know that this function really only uses x values that are less than -2. But we'll make that adjustment in a couple of moments. The next function, f of x equals -1/2 x plus 1. Here it is. It's supposed to be a dark red color. And the third one, f of x equals x minus 6, is here in green. So we're looking at all three of these functions, all graphed using all x values. We want to trim these down based on the restrictions on our x values. The first one is the one in purple right here, f of x equals -2x minus 5. But we're saying that this one is only used for x values that are less than -2. So we're going to use this tail end here, but once we get to -2, we're going to chop that graph off. So it exists only for x values that are less than -2. The middle function, f of x equals -1/2 x plus 1, this one is only used for x values that are between -2 and +4. So let's chop off these two pieces on the left and the right so that we're only looking at the graph between -2 and +4. The last graph, x minus 6, and this graph is used only for x values that are greater than 4. So we'll keep this branch that is 4 and greater, and chop off this part that has x values less than 4. And there's the graph of our piecewise function. Now, we did talk about those questions like what is f of 0 and what is f of 4. So now we can really see f of 0, it has only one value. When x equals 0, the value of our function is right here at positive 1. Same thing that we found algebraically. The other question was, what is f of 4? And it's not very clear on this graph which of these two pieces we should use, the one in the dark red or the one in green. What we really should have on these endpoints are some better clues about which piece is really at work on one of these boundary points. And I want to say that where we have these breaks in our graph, I'm going to call these x values the boundary points. So negative 2 is a boundary point, and positive 4 is a boundary point. It's right on the boundary between two different pieces. So let's resolve this issue, and at the same time talk about how we would make these graphs by hand. To make the graphs by hand, look at each function one at a time. And for making graphs, I like to make a table. Our first function was the negative 2x minus 5. I'll make a quick table here where I can choose x values. In the middle, I'll do my plugging in for the x value and simplify, and I'll put my result here as our final function value, and that's going to be our x coordinate and our y coordinate that we plot. Now remember, this function applied only for x values that were less than negative 2. So in my table, I only want to use x values that are less than negative 2. And I would also recommend that we actually use those boundary points. So negative 2 was a boundary point, I'll use that. And then I'll choose other values that are less than negative 2. So I'll go with negative 3 and negative 4. Now one at a time, we're plugging in the x value in place of this x. And I'll simplify, so this would be a positive 4 minus 5 equals negative 1. That will be a point that we plot. Then if x is negative 3, negative 2 times negative 3 is positive 6 minus 5 gives us positive 1. And this last point, x equals negative 4. Negative 2 times negative 4 is 8. 8 minus 5 equals 3. So we have some ordered pairs that we can plot for the first piece of this function. I'll start with the point negative 4, 3, and then we have the point negative 3, 1, and the last point was negative 2, negative 1. But remember, that boundary point was not included in this piece. This piece was for x values that are less than negative 2, less than but not equal to. So I have an open circle on that boundary point because negative 2 is really not included in this piece. It will be included in the next piece. Now this is a linear function, so I'll go ahead and connect those points with a straight line, a little arrowhead to say that the line will continue in this direction as your x values get smaller and smaller, but we know that it stops once we get to our x value of negative 2, and that's where the next piece begins. So I'll write our next function, negative 1/2 x plus 1. I'll put this into a table. This function used x values that were between negative 2 and positive 4. So in my table, I'll use negative 2 and positive 4, and I'll pick one more value in between because I like to plot 3 points when plotting lines. So again, same business. We're plugging these x values in place of x in this expression, and we'll simplify to find our final function value. If x is negative 2, we have negative 1/2 times negative 2, that's positive 1, plus 1 equals 2. Next, if x equals 0, we're plugging that in. That's a quick one. 0 plus 1 equals 1. And lastly, if x equals 4, negative 1/2 times 4 plus 1, so that's negative 2 plus 1 equals negative 1. Now we have 3 ordered pairs that we can plot for this middle piece. Negative 2, 2, have that point plotted, and then 0, 1, and lastly 4, negative 1. Now remember, what were our x values that we could use in this piece? In between negative 2 and positive 4, and negative 2 was included, but 4 was not. So we have an open circle for x equals 4. Now it's another linear function, so we'll connect those points with a nice straight line. Now our last piece was the function x minus 6. Do a quick table here. this function was used for x values that were greater than or equal to 4. So I'll start with that boundary point 4 and pick some x values that are greater, 5 and 6. So we're doing the plugging in business, 4 minus 6, negative 2, 5 minus 6, negative 1, 6 minus 6, 0. Let's plot those points. 4, negative 2, so we're just below that piece. 5, negative 1, 6, 0. This is another linear piece, so we'll connect those with a nice straight line and arrowhead to say this graph continues in this direction as we get x values that are even larger and larger and larger. So there's our finished graph, and we accomplished it by looking at the functions one at a time and being very careful about those restrictions on the x values. That helped us decide what x values we should put into each of these tables. And just a quick reminder of how that first graph looked, the one that we had the program do for us. So we got a good match here. The one we did by hand matches up pretty well. So here's our next example. You can do one of two things. You could either pause the video right now and give this function a shot, and I think I might recommend that you try that. And once you've tried it out, then restart the video, and we're about to go through the solution together. This piecewise function has 4 pieces. It's made up of 4 functions: f of x equals negative 5, f of x equals x minus 1, f of x equals x squared plus 1, and f of x equals 10. And here we see which x values should be used with each of these functions. So one at a time, that first function was f of x equals negative 5, and it is using x values that are less than 4. So I'll make a table. I'm going to make a quick table this time because it is a constant function, so I know that f of x will always equal negative 5. But I'm still careful about my choices for x values. They have to be less than negative 4. So I'll start with that boundary point negative 4 and choose a couple more x values that are less than negative 4. It is this constant function f of x equals negative 5, so negative 5 down the list here for our function values, or the y coordinates that we will plot. I'm going to do one more thing just to help me be accurate with my graph. Just a little reminder that x equals negative 4 is not part of this graph. It's a boundary point, but our inequality symbol says less than negative 4, but not equals. So when I go to plot this point, I'll be sure that I use an open circle. What is our next function? It's f of x equals x minus 1, and this function we used only with x values that were between negative 4 and 0. And we can have x values that include negative 4, but do not include 0. They go right up to 0 at that boundary, but it does not actually include 0. So we'll need to use another open circle when we get there. A quick table, and I'm choosing x values that are between negative 4 and 0. And I do like to use those boundary points, so I'll use x values of negative 4 and 0, and I'll pick one more point in between, negative 2, right in between. Now, one at a time, we're plugging these x values into this expression x minus 1. So negative 4 minus 1, negative 5. Negative 2 minus 1, negative 3. And if x equals 0, this is 0 minus 1 equals negative 1. And a quick little reminder that when I go to plot this last point, when x equals 0, that's an open circle. Because of this inequality symbol, it does not have the equals part, so we'll need to use open circle. I don't care to use an open circle with negative 4 because in this case negative 4 is included. We have this equals part to our inequality. So moving on to the third piece, f of x equals x squared plus 1. This function uses x values that are between 0 and 3. It does include 0 but does not include 3. I'll set up a table. My x values, I'm going to use 0 and 3, and I'll pick another x value in between them. I'll pick 1. Now we're plugging in. This time we don't have a linear, we have actually a parabola. This is a quadratic function. But 0 squared plus 1 equals 1, 1 squared plus 1 equals 2, and then a quick jump over to 3, 3 squared plus 1 equals 10. And we can even see that we don't have this constant change here of our y values. Last piece, let's throw an open circle reminder there because 3 is not included. So when we plot that point 310, we'll use open circle. Now to that last piece, f of x equals 10. another constant function. Now this was using x values that are greater than or equal to 3. So I can do a quick table because it's a constant function, but still I'm cautious about my choices for x values, 3 and bigger. So 3, 4, 5 makes sense, and the function value is 10 for each of those x values. And I don't need to use an open circle with any of these points because x is greater than or equal to 3. So these points 3, 4, 5 will all be included in this last piece. So now let's get to making the graph, and I'll make the graph by doing these pieces one at a time as well. So we're going to plot this first table of ordered pairs, and we'll be sure to use an open circle when we get to the point -4, -5. And if you're following along, you might want to jot these tables of ordered pairs down because we're going to move over to a page to make the graph here. So that first table was -4 with -5, -5 with -5, and -6 with -5. And there's the open circle at that point, -4, -5. It's a linear function, so we'll connect it with a line and get that arrowhead out to the left to say it continues this way for all x values less than -4. So that first piece is graphed. Here's our next table that we'll use. So we're going to end up plotting these 3 points now with an open circle on the last point. So -4, -5, there's our point right there. Now in this case, our 2 pieces are actually going to connect to one another. It doesn't always happen. We saw in the first example that we had 3 separate pieces. But here's an example where our second piece picks up right where that first piece left off. So I'm just going to fill in that open circle now. And it is linear between these 2, so we'll connect with a straight line. Our second piece is now graphed. The third piece, let's hop back to those tables. Here we go, 0, 1, 1, 2, and then 3, 10, and we'll have an open circle at 3, 10. There are those points, and it is part of a parabola, so I do want to see a nice sort of curve forming here. There we go. And lastly, our constant function when f of x equals 10, and x has values that are greater than or equal to 3. So 3, 10, 4, 10, 5, 10, we're going to plot those points. And another example where our fourth piece picked off where the last piece ended. So we can fill in that open circle. And this is another linear, so we'll connect with a line and get it extended to the right with this arrowhead saying that our function is going to equal 10 for all of these x values that are greater than 3. So there's our final graph. We had a couple places where the 2 pieces were continuous. One picked up right where the other one left off, but we also had an example here where 2 pieces didn't connect. It's not continuous, so we have a little jump here. And there's our finished graph.